Now, in this lecture, we will find the area of the green shape in three different ways. In the drawing, we have a circle. We know that the radius of this circle equals to 5 units. And we also know that CA is tangent to this circle at point A, and CB is tangent to this circle at point B. Angle ACB equals to 60 degrees, and we want to find out the area of the green shape. Okay, so we will start with the first method. First of all, we will define the center of this circle as point O. Then we will join together points A and O by a straight line. Actually, AO is the radius of this circle that equals to 5 units. And we will also join together points O and B by a straight line. OB is also the radius of this circle that equals to 5 units, because of the fact that line segment OB starts from the center of this circle, that is to say from point O, and ends at point B, that is a point on the circle itself. Therefore, OB is the radius of this circle. Okay, and we actually have a rule that a tangent to a circle is perpendicular to the radius drawn to its tangency. So, okay, if we have a circle and we have tangent to this circle, BX is tangent to this circle at point C, and we have radius that is drawn to the point of tangency, that is to say to point C. Actually, this radius touches point C. Then, according to the rule that I stated, the tangent is perpendicular to this radius, that is to say this angle is a right angle, it equals to 90 degrees, and also here we have 90 degrees. Again, the rule states that a tangent to a circle is perpendicular to the radius drawn to its tangency. I will read the rule again. The rule states that a tangent to a circle is perpendicular to the radius drawn to its tangency. So actually here we have tangent xb is tangent to this circle at point C. So point C is the point of tangency, and the radius, this radius is drawn to the point of tangency, that is to say, it is drawn to point C. Therefore, the tangent is perpendicular to the radius, that is to say, this angle is 90 degrees and this angle is also 90 degrees. Okay, so according to this rule, we have here tangent CB and the radius that it is drawn to the point of tangency, that is to say point B. Therefore, the tangent CB is perpendicular to the radius, that is to say this angle equals to 90 degrees. And the same thing is true here. We have tangent CA is tangent to this circle at point A, and we have this radius that is drawn to the point of tangency. Actually it touches the point of tangency. Therefore the tangent is perpendicular to the radius, that is to say this angle equals to 90 degrees. It is a right angle. Okay. We have another rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. Again, the sum of the angles in any quadrilateral is equal to 360 degrees. If we look at quadrilateral ABCO, we know that the sum of the angles in quadrilateral ABCO must be equal to 360 degrees. So what are the angles of quadrilateral ABCO? The angles are, here it is 60 degrees plus 90 degrees plus 90 degrees plus this angle, that is angle AOB, so in total those four angles must be equal to 360 degrees. Okay, so the sum of the angles in quadrilateral ABCO equals to 360 degrees. Okay, so here we have 60 degrees plus 90 degrees plus 90 degrees is equal to 240 degrees. So I will write it down. (240 degrees) plus the size of angle AOB must be equal to 360 degrees. So here we will subtract 240 degrees from this equality, and we will get that the size of angle AOB equals to 360 degrees minus 240 degrees is 120 degrees. Okay, so angle AOB, this angle equals to 120 degrees in its size. Okay, in the next step, we will connect together points C and O by straight line. And we will focus on triangles AOC and triangle BOC. So on those two triangles, we know that AO equals to BO equals to the radius of this circle that equals to 5 units. Okay, AO equals to BO equals to the radius of this circle that equals to 5 units. And actually AC equals to BC according to two tangents theorem. So, what is two tangents theorem? First of all, I will write down the rule of two tangents theorem, and then I will explain it. Two tangents theorem states that the lengths of two tangents from a common external point the lengths of two tangents from a common external point to a circle are equal. So I will read again the two tangents theorem. Two tangents theorem states that the lengths of two tangents from a common external point to a circle are equal. So actually here, if we have external points to this circle, that is to say, this point, we'll call it point C, and from point C we draw two tangents to this circle. This is the first tangent. This tangent is tangent to this circle at point B. And we have the other tangent to this circle at point D. Then, so according to this two tangents theorem states that whenever you draw two tangents from a common external point, that is to say, from point C to the circle, the lengths of those two tangents will be equal to each other. That is to say, DC equals to CB. DC equals to BC, according to two tangents theorem. Okay, those two tangents are equal in their sizes. Okay, DC equals to BC. So according to this rule, in the drawing we have a common external point, that is to say point C, and from point C we draw two tangents. CA is tangent to this circle at point A, CB is tangent to this circle at point B. So according to two tangents theorem, those two tangents that are drawn from a common external point, that is to say point C, will be equal to each other in their sizes. That is to say, BC equals to AC. BC equals to AC. Those two sides are equal to each other in their sizes, according to two tangents theorem. Okay, we will return to those two triangles. We proved the two sides of those two triangles are equal to each other. AO equals to BO, AC equals to BC according to two tangents theorem. And we also know that OC is a common side. It belongs to it belongs to both triangles, to triangle AOC and to triangle BOC. So therefore OC equals to OC. It is a common side. OC equals to OC, it is the common side. So we actually proved that all the sides of triangle OCB are equal to all the sides of triangle OSC. Therefore, those two triangles can go into each other according to side rule. Triangle AOC can go into triangle BOC. According to side rule. Okay, those two triangles can go into each other according to side rule. Because of the fact that those two triangles can go into each other, we can derive from it that angle OCA is equal to angle OCB. Those two angles are equal to each other. Again, angle OCA equals to angle OCB according to the rule that corresponding angles in congruent triangles are equal to each other. Okay, triangle AOC congruent to triangle BOC, therefore the corresponding angles, those two angles, are also equal to each other. Okay, so those two angles are equal to each other, so if we define one angle as x, then the other angle will be also equal to x. Okay, so we define angle OCA as x, then angle OCB will be also equal to x. So the size of this angle is 2x, and we know that this angle ACB equals to 60 degrees. So we get the equality that 2x equals to 60 degrees. We divide this equality by 2, and we will get that x equals to 30 degrees. So the side of this angle is 30 degrees, and the size of this angle also is 30 degrees. And we will focus on the right triangle, triangle AOC. So in the right triangle, triangle AOC, so on the right triangle, triangle AOC, we know that tangents 30 degrees equals to AO over AB. Again, in triangle, the right triangle AOC, tangents 30 degrees equals to AO over AB. But we know that AO equals to 5 units. It is the radius of this circle, so we substitute AO by 5. Over AC. Okay, we know that tangent 30 degrees equals to 1 over root 3, so I write it down. So tangent 30 degrees equals to 1 over root 3. We got this equality. 1 over root 3 equals to 5 over AC. We will multiply this equality by AC. We will get that AC over root 3 equals to 5. So here we will multiply this equality by root 3 in order to get the value of AC. We will get that the value of AC is 5 times root 3 units. Okay, the value of AC equals to 5 times root 3 units. So we can write here that AC equals to 5 times root 3 units. But because of the fact that AC equals to BC according to two tangents theorem, BC will be also equal to 5 times root 3 units. And what is the area of triangle AOC? The area of triangle AOC. So this expression means that the area of triangle AOC. Okay, the area of triangle AOC, that is the way that we write it. That is the area of triangle AOC. the area of triangle AOC equals to the base of the triangle times the height to the base over 2. So the area of triangle AOC equals to the base of the triangle times the height to the base over 2. So here in the drawing we can see that the area of triangle AOC equals to the base is AO and the height is AC over 2. So the area of triangle AOC equals to the base that is AO times the height to the base that is AC over 2. But we know that AO equals to 5 units. This is the radius of this circle, so we can substitute AO by 5. And we also know that AC equals to 5 times root 3. So we substitute AC by 5 times root 3 over 2. So the area of triangle AOC equals to 5 times 5 times root 3 over 2. 5 times 5 is 25, so I write it down. The area of triangle AOC will be equal to 25 times root 3 over 2 square units. Okay, that is the area of triangle AOC. Okay, and we also know that because of the fact that triangle AOC is congruent to triangle BOC, the areas of those two triangles are equal to each other. That is to say, the area of triangle AOC is equal to the area of triangle BOC. Okay, the area of triangle AOC equals to the area of triangle BOC, and what is the area of quadrilateral ABCO? The area of quadrilateral ABCO, it consists two triangles, so the area will be equal to the sum of those two triangles. The area of triangle ABCO will be equal to the area of triangle AOC plus the area of triangle BOC. Okay, the area of quadrilateral ABCO equals to the area of triangle AOC plus the area of triangle BOC. But we have already found out that the area of triangle BOC equals to the area of triangle AOC. So we can substitute the area of triangle BOC in this equality by the area of triangle AOC because they are equal to each other. So when we substitute it, we get that the area of quadrilateral ABCO is equal to the area of triangle AOC plus the area of triangle AOC. We substituted the area of triangle BOC by the area of triangle AOC because they are equal to each other. So actually the area of quadrilateral ABCO equals to 2 times the area of triangle AOC. Okay, Again, the area of quadrilateral ABCO equals to 2 times the area of triangle AOC. But we have already found out that the area of triangle AOC equals to 25 times root 3 over 2 square units. So we can write down that the area of quadrilateral ABCO equals to 2 times the area of triangle AOC, that equals to 25 times root 3 over 2. So here we have 2 over 2, so 2 will be cancelled. We can cancel, then we'll get that the area of quadrilateral ABCO equals to 25 times root 3 square units. The area of quadrilateral ABCO equals to 25 times root 3 square units. Okay. But what is the area of the green shape? The area of this green shape equals to the area of quadrilateral ABCO minus the area of sector AOB. Again, the area of quadrilateral ABCO minus the area of sector AOB will be equal to the area of the green shape. So I write it down. The area of quadrilateral ABCO minus the area of sector ABO equals to the area of the green shape. Again, the area of quadrilateral ABCO minus the area of sector ABO equals to the area of the green shape. Okay. The area of quadrilateral ABCO minus the area of sector ABO equals to the area of the green shape. We have already found out that the area of triangle ABCO equals to 25 times root 3 square units. So the only thing that is left to find is to find out the area of sector ABO. The area of this sector ABO will be equal to the area of the circle, that is pi r square, times 120 degrees over 360 degrees. R equals to 5, so pi r square will be equal to 25 pi, and 120 degrees over 360 degrees equals to 1 over 3. So in total we will get that the area of sector ABO will be equal to 25 pi over 3 square units. So the area of sector ABO equals to 25 pi over 3 square units, and the area of quadrilateral ABCO equals to 25 times root 3 square units. Okay. So the area of quadrilateral ABCO minus the area of sector ABO will be equal to the area of the green shape. Or in other words, the area of the green shape will be equal to the area of quadrilateral ABCO that equals to 25 times root 3 square units minus the area of sector ABO that is 25 pi over 3 square units. So we found out that the area of the green shape equals to 25 times 3 times root 3 square units minus 25 pi over 3 square units. That is the area of the green shape. Again, the area of the green shape equals to the area of quadrilateral ABCO minus the area of sector ABO. That is 25 times root 3 minus 25 pi over 3 square units. Okay, so in the next step we will find out the area of this green shape according to a second method. We will define the center of this circle as point O. Then we will join together points C and O by a straight line. Then we will extend line segment CO until it touches the circle at point H. Then we will draw a tangent to this circle at point H. Actually, OH is the radius of this circle because of the fact that it starts from the center of the circle and ends at point H, that is a point on the circle itself. Therefore, OH is the radius of this circle that equals to 5 units. We have tangent and radius. We know that the radius that is drawn to the point of tangency is perpendicular to the tangent, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. In the next step we will extend AC until it intersects with the tangent. The intersection point between the tangent and AC will be defined as point P. Again, point P is the intersection point between AC and the tangent. Then we will also extend line segment CB until it intersects with the tangent, and we will define the intersection point between the tangent and CB as point Q. Again, point Q is the intersection point between CB and the tangent PH, and according to what I have already showed to you in method 1, this angle is 30 degrees and this angle is also 30 degrees, but I will explain you one more time why they are equal to 30 degrees each other. We will join points O and A together by a straight line. OA is the radius of the circle that equals to 5 units. We will join points O and B together by a straight line. OB is also the radius of this circle that equals to 5 units. If we focus on those two triangles, triangle AOC and triangle BOC, we know that AO equals to BO because both of these line segments are the radiuses of this circle, therefore they are equal to each other. So AO equals to BO, AC equals to BC according to two tangents theorem, and CO equals to CO is a common side, therefore triangle ACO is congruent to triangle BCO, and from the fact that those two triangles congruent to each other, we can deduce that angle ACO, this angle, is equal to angle BCO, this angle. Those two angles in the red color are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. So if we define one angle as x, then the other angle will be also equal to x. X plus x is 2x, so 2x equals to 60 degrees. And if we divide the equality to x equals to 60 degrees by 2, we will get that x equals to 30 degrees. So this angle is 30 degrees and this angle also equals to 30 degrees. Okay? So in the right triangle ACO, we know that tangent 30 degrees equals to AO over AC. And after we solve this simple equality that tangent 30 degrees equals to AO over AC, we will get that AC equals to 5 times root 3 units. AC equals to BC, so BC also equals to 5 times root 3 square root 3 units. And now we will focus on the right triangle, triangle PCH. We know that the sum of the angles in any triangle equals to 180 degrees. So the sum of the angles in the right triangle, triangle PCH equals to 180 degrees. That is to say 30 degrees plus 90 degrees plus the size of this angle equals to 180 degrees. Or 120 degrees plus the size of this angle equals to 180 degrees, we will subtract 120 degrees from the equality, and we will get that the size of this angle equals to 60 degrees. We will repeat on the same process on the right triangle CHQ, and we will get that angle HQC or angle PQC, this angle also equals to 60 degrees. For the same reason, we know that the sum of the angles in triangle CHQ equals to 180 degrees, so 30 degrees plus 90 degrees plus the size of this angle must be equal to 180 degrees. We will subtract from the equality 180 degrees, and we will get that the size of this angle equals to 60 degrees. So triangle CPQ is a right triangle because triangle CPQ is an equilateral triangle because it has three angles that equal to 60 degrees. Okay? And we have a rule that states that the center of a circle inscribed in a triangle is the incenter of the triangle. Therefore, according to the rule, the center of this circle that is at point O is also will be the center of triangle CPQ. So the center of triangle CPQ is at point O. And we have another rule that says that the height from the center of an equilateral triangle crosses the sides. So according to that rule, we know that the center of the equilateral triangle PCQ is at point O, and according to the rule that I mentioned, the height from the center, that is to say from point O, crosses the side, that is to say the height divides the side CQ to two equal parts, that is to say CB equals to BQ. Okay, CB equals to BQ, but we know that CB equals to 5 times root 3, so BQ will be also equals to 5 times root 3. The same thing is in the other side. We know that the height, this angle is 90 degrees. This angle is also 90 degrees. So the height, it is the height because it makes 90 degrees with PC. So the height from the center of the triangle, that is point O, the height divides the side PC to two equal parts. That is to say AC equals to AP. But we know that AC equals to 5 times root 3 and AP equals to AC. So AP will be also equal to 5 times root 3 units. Okay, and we know that in an equilateral triangle, all the sides are equal to each other. So one side of this equilateral triangle equals to 5 times root 3 plus 5 times root 3. That is to say, one side of the equilateral triangle PCQ equals to 10 times root 3. That is to say, PQ also equals to 10 times root 3. And we have the rule that the height from the center of this equilateral triangle, that is to say OH, that is the height from the center of this equilateral triangle divides the side to two equal parts. That is to say, PH equals to HQ. If PH is X, then HQ also it will be equal to X. So PQ equals to 2X. From one side PQ equals to 2X. From the other side PQ equals to 10 times root 3 because it is a side of equilateral triangle. So 2X equals to 10 times root 3. If we divide this equality by 2, we will get that X equals to 5 times root 3. That is to say, PH equals to 5 times root 3. And HQ also equals to 5 times root 3. Okay? And what is the area of an equilateral triangle? If we have any triangle, that is to say triangle ABC, that can be any triangle, and we know that the size of AB is A units and the size of AC is B units, and we also know that the angle between side AB and side AC is theta. Then the area of this triangle will be equal to A times B times sine theta over 2. That is the area of triangle ABC. The area of this triangle ABC is A times B times sine theta over 2. So if we will use this formula in order to find out the area of the equilateral triangle PCQ. According to this formula, the area of triangle PCQ will be equal to the area of equilateral triangle PCQ will be equal to PC times CQ times sine 60 degrees over 2. So again, the area of triangle PCQ according to the formula that I presented to you will be equal to PC times CQ times sine 60 degrees over 2. But we know that PC equals to CQ. It is equilateral triangle, PC equals to CQ. And each side equals to 5 root 3 plus 5 root 3 is 10 root 3. So it is actually 10 root 3 square. And sine 60 degrees is root 3 over 2, and root 3 over 2 is root 3 over 4. So the area of triangle PCQ equals to the area of triangle PCQ equals to root 3, 10 times root 3 square times root 3 over 4. 10 times root 3 square is 300. 300 over 4 is 75. So in total we got that the area of equilateral triangle CPQ equals to 75 times root 3 square units. And what is the area of the circle? The area of the circle equals to pi r square. And we know that r equals to 5, so r square is 25. So the area of this circle equals to 25 pi square units. So the area of equilateral triangle PCQ minus the area of the circle will give us the area of the green shape plus the area of the yellow shape plus the area of the blue shape. Again, the area of triangle PCQ minus the area of the circle will give us the area of the green shape plus the area of the yellow shape plus the area of the blue shape. But as you can see from the drawing, those three shapes are identical. The green shape and the yellow shape and the blue shape are identical to each other, therefore they have also the same area. So if we define the area of the green shape as x, then the area of the yellow shape will be also equal to x, and the area of the blue shape will be also equal to x. So the sum of the areas of the three shapes will be equal to x plus x plus x, that is to say will be equal to 3x. Okay? So the area of triangle PCQ, the area of equilateral triangle PCQ minus the area of the circle equals to the area of the three shapes, the area of the green shape plus the area of the yellow shape plus the area of the blue shape. And we defined the area of each shape as x. So the area of the triangle PCQ minus the area of the circle will be equal to 3x. So we know that the area of the green shape equals to x. So in order to get the area of the green shape, we'll divide this equality by 3 and we will get the area of the green shape. So the area of the green shape, that is x, will be equal to the area of triangle PCQ minus the area of the circle over 3. X over 3 is x, and x is the area of the green shape according to our definition. Okay, so the area of the green shape equals to the area of equilateral triangle PCQ minus the area of the circle over 3. What is the area of triangle PCQ? The area of triangle PCQ equals to 75 times root 3 square units. What is the area of the circle? The area of the circle equals to 25 pi. So if we divide this equality by 3, we will get the area of the green shape. That is the area of the green shape. The area of the green shape will be equal to 75 over 3 is 25 times root 3 minus 25 pi over 3 square units. Okay, so we found out that the area of the green shape according to the second method equals to 25 times root 3 minus 25 pi over 3 square units. Okay, in the next step we will find the area of this green shape in a third method. We will join together points A and B by a straight line. And we will focus on triangle ABC. We know that AC equals to BC according to two tangents theorem, and we know that in front of equal sides there are equal angles, so those two angles are equal to each other. If this angle equals to x, this angle will be also equal to x. So the sum of the angles in triangle ABC equals to 180 degrees, so 60 degrees plus x will be equal to 180 degrees. We will subtract 60 degrees from the equality and we will get that 2x equals to 120 degrees. We will divide this equality by 2 and we will get that x equals to 60 degrees. So this angle is 60 degrees and this angle is also 60 degrees. Okay, so triangle ABC is an equilateral triangle, and we will define the center of this circle as point O, and then we will join together points O and B by a straight line. OB is the radius of this circle that equals to 5 units, and this angle is 90 degrees, as I have already proved in the previous methods. We will join together points A and O by a straight line. AO is the radius of this circle that equals to 5 units, and this angle is equals to 90 degrees according to what I proved to you in the previous methods. We will join together points O and C by a straight line. I've already proved that those two triangles can go into each other. Triangle OCB can go into triangle OAC. From the fact that those two triangles can go into each other, we can conclude that those two angles are equal to each other. Therefore, this angle equals to 30 degrees, and this angle also equals to 30 degrees. In triangle OAC, we know that triangle 30 degrees equals to AO over AC. From that equality, the triangle 30 degrees equals to AO over AC. We will get that AC equals to 5 times root 3 units, and AC equals to BC, so BC also equals to 5 times root 3 units. So the area of the green shape equals to the area of equilateral triangle ABC minus the area of the circular segment AB. Again, the area of the green shape equals to the area of the equilateral triangle ABC minus the area of circular segment AB. The area of triangle ABC minus the area of this circular segment AB equals to the area of the green shape. Again, the area of triangle ABC minus the area of this circular segment AB equals to the area of the green shape. Very simple. And what is the area of triangle, equilateral triangle, triangle ABC. As I have already proved in the previous methods, the area of equilateral triangle equals to x squared times root 3 over 4 square units. So the area of triangle ABC, that is equilateral triangle, will be equal to x squared times root 3 over 4 units. But we know that x, the size of one side of triangle, equilateral triangle ABC, equals to 5 times root 3. So x equals to 5 times root 3. Or the area of equilateral triangle, triangle ABC, equals to 5 times root 3 squared times root 3 over 4 square units, and 5 times root 3 squared is 75. So in total it equals to 75 times root 3 over 4. Again, the area of equilateral triangle, triangle ABC, equals to 75 times root 3 over 4. Okay? And what is the area of circular segment AB? The area of circular segment AB equals to the area of sector AOB minus the area of triangle AOB. Again, the area of this shape, circular segment AB, equals to the area of sector AOB minus the area of triangle AOB. Very simple. How we can get the area of circular segment AB? We will subtract the area of triangle AOB from the area of the sector AOB. Okay, the area of circular segment AB equals to the area of sector AOB minus the area of triangle AOB. We have already found out that the area of sector AOB equals to pi r squared times 120 degrees over 360 degrees, that is 25 pi over 3 square units. The area of sector AOB equals to 25 pi over 3 square units, and the area of triangle AOB, this triangle, equals to 5 times 5 times, this angle is 120 degrees. We have already found out in the previous method that this angle is 120 degrees. So the area of triangle AOB equals to 5 times 5 times sine 120 degrees over 2, that is to say it equals to 25 over 25 times root 3 over 4 square units. So we found out that the area of circular segment AB equals to this expression, and we know that the area of the green shape equals to the area of equilateral triangle ABC minus the area of circular segment AB. Again, the area of the green shape equals to the area of the equilateral triangle, triangle ABC, minus the area of circular segment AB. we have already found out that the area of triangle ABC equals to 75 times root 3 over 4 square units, and the area of circular segment AB is this expression. So we will copy this expression, 25 pi over 3 minus 25 times root 3 over 4. So the area of the green shape equals to this expression. Here we will open the brackets and we will get that the area of the green shape equals to 75 times root 3 over 4 minus 25 root 3 over 4, minus and minus is plus, so it is 75 plus 25 is 100 root 3 over 4 minus 25 pi over 3 square units. So after we opened the brackets in this expression, we got that the area of the green shape equals to this expression. 100 over 4 is 25, so I write it down. So we get that the area of the green shape equals to 25 times root 3 minus 25 pi over 3 square units. Okay, again, the area of the green shape according to the third method equals to 25 times root 3 minus 25 pi over 3 square units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the area of the green shape. We found out the area of this green shape in 3 different ways. In the first method, according to the first method, the area of the green shape equals to the area of quadrilateral ABCO minus the area of sector ABO. Okay? And first of all, we define the center of this circle as point O, then we join together points A and O by a straight line. AO is the radius of this circle, because of the fact that it starts from the center of the circle and ends at point A, that is the point on the circle itself. From the same reason, OB is also the radius of this circle. And this angle is 90 degrees, and this angle is also equals to 90 degrees, according to the rule that a tangent to a circle is perpendicular to the radius drawn to its tangency. So, according to this rule, if we have a circle and a tangent to this circle, tangent BX is tangent to this circle at point C, and we have the radius of this circle that is drawn to the point of tangency, that is to say to point C, then the tangent BX will be perpendicular to this radius, that is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. For that, so according to that rule, we have here tangent AC that is tangent to this circle at point A, and we have this radius that is drawn to the point of tangency, that is to say to point O. Then therefore the tangent is perpendicular to this radius, that is to say this angle is 90 degrees. The same rule is also here. We have tangent CB that is tangent to this circle at point B, and we have the radius that is drawn to the point of tangency, that is to say to point B. Therefore this tangent is perpendicular to this radius, that is to say this angle is 90 degrees. Okay, and we also have a second rule. If we have external point to this circle, that is to say point C, and from point C we draw two tangents to this circle, then those two tangents will be equal to each other in their sizes. Or according to two tangents theorem, the lengths of two tangents from a common external point to a circle are equal. Okay, so if we have here external point C, and from point C we draw two tangents to this circle, tangent CB that is tangent to the circle at point B, and tangent CD that is tangent to the circle at point D, then those two tangents will be equal to each other in their sizes, that is to say CB equals to CD. So according to the two tangent theorem, AC equals to BC. So we also have a rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees, and especially the sum of the angles in quadrilateral ABCO equals to 360 degrees. That is to say 60 degrees plus 90 degrees plus 90 degrees plus the size of this angle equals to 360 degrees. Okay, 60 degrees plus 90 degrees plus 90 degrees plus the size of angle AOB equals to 360 degrees. From this simple equality we got that the size of angle AOB, the size of this angle is 120 degrees. The size of this angle AOB equals to 120 degrees. Then we join together point C and O by a straight line, and we proved that this triangle BOC is congruent to triangle AOC, because we know that AO equals to BO, which is the radius of this circle. We also know that AC equals to BC according to two tangent theorem, and CO equals to CO, which is a common angle. Therefore, we proved that triangle BOC is congruent to triangle AOC according to two tangents theorem. From the fact that those two triangles congruent to each other, we can derive that angle BCO in this triangle equals to angle ACO in triangle AOC. Those two angles are equal to each other. Okay? So if we define one angle as x, this angle is x, then this angle will be also equal to x. Or x plus x is 2x, 2x equals to 60 degrees. 2x equals to 60 degrees, therefore x equals to 30 degrees. So this angle is 30 degrees and this angle is 30 degrees. And in the right triangle AOC, we know that tangent 30 degrees equals to AO over AC. Tangent 30 degrees equals to AO over AC. So from this equality, we got that the value of AC equals to 5 times root 3 units. And what is the area of triangle AOC? The area of triangle AOC equals to the base of the triangle times the height over 2. According to this formula, we got that the area of triangle AOC equals to 25 times root 3 over 2 square units. But because of the fact that the area of triangle AOC is congruent to triangle BOC, they have also the same areas, or the area of triangle AOC equals to the area of triangle BOC. The area of triangle AOC equals to the area of triangle BOC. And what is the area of quadrilateral ABCO? The area of quadrilateral ABCO equals to the area of triangle AOC plus the area of triangle BOC. But we have already found out that the area of triangle AOC equals to the area of triangle BOC, so if we can substitute the area of triangle BOC by the area of triangle AOC because they are equal to each other. So we got that the area of quadrilateral ABCO equals to 2 times the area of triangle AOC, and we have already found out that the area of triangle AOC equals to 25 times root 3 over 2 square units. So we found out that the area of quadrilateral ABCO equals to 25 times root 3 square units. And we know that the area of quadrilateral ABCO minus the area of sector ABO equals to the area of the green shape. Equals to the area of the green shape. So what is the area of sector ABO? The area of sector ABO equals to pi r squared times 120 degrees over 360 degrees. That is to say the area of sector ABO equals to 25 pi over 3 square units. So the area of quadrilateral ABCO minus the area of sector ABO equals to the area of the green shape. Or the area of the green shape equals to 25 times root 3 minus 25 pi over 3 square units. Then we found out the area of the green shape in a second method. Actually, we extended AC and BC until they touch the tangent edge, and in this way we created equilateral triangle CPQ, and the area of triangle CPQ minus the area of the circle over 3 equals to the area of this green shape. Okay, so that was the second method, and in the third method we connected points A and B together. In this way we created the equilateral triangle ABC, and the area of triangle ABC minus the area of circle segment AB equals to the area of the green shape. Again, the area of equilateral triangle ABC minus the area of this circle segment AB equals to the area of the green shape. Okay, so the area of the green shape equals to 25 times root 3 minus 25 pi over 3 square units. Okay, so we found out in 3 different ways the area of this screen shape. Okay, thank you very much.